Hi everybody, I wanted to give you just kind of a quick review of z-scores and x-scores and to talk to you a little bit about area under the curve. So anytime that you know that you are working with a normal curve, then you are really golden, because what that means is that you then know that you can identify various places on this curve so that you can figure out probabilities of the likelihood of a value being this big or that big or whatever it might be. And so anytime that you have this normal curve, you know for a fact that the line that divides the space or the distribution, the probability distribution in half, is right smack in the middle where the mean of the z-scores is 0 and where the value of x is equal to mu, right? So this value right here at the bottom is the place where x is equal to the mean, or mu, and z is equal to 0, okay? What you also know is that the curve itself is divided up, or is identifiable by places on the x-axis that can represent x or z. So, for instance, if you come out here to the right and have a line right here, then if you have information about that line, you can go between x or z or the probability. So if you're told, for instance, that the space over here represents, say, I don't know, what does that look like to you guys? Say that that percentage is like the top 40% of the curve, right? Then you can use the z-table in the back of your book to find out that 40% of the curve equates to a z-score of about 0.25. So the way that you get that is you just look this up as the tail value to identify what the z-value is. So when you do that, you find out that the z-value is 0.25. Of course, it's positive because I'm on the positive side of the mean. So once you know that the z is 0.25, you can figure out what the x value there is if you know x, if you know mu and sigma. And so what's so fun to me about z-scores is that it allows you to go back and forth between these various sort of aspects of this curve, if you will. So if I give you an x, if you know mu and sigma, then you can figure out z, and once you know z, you can figure out the area under the curve. If I give you z and you know sigma and mu, then you can figure out an x. If I give you a probability, you can find a z, and then if I give you sigma and mu, you can find an x. So it's just, to me, it's super fun, and you can just go back and forth, but I just wanted to make sure you guys kind of understood that these things are all just related. So when you're asked questions about this, I would strongly encourage you to draw this figure out, put down what you know, put down if you're given z or if you're given x, write down what the mu is, write down the proportions or the probabilities, write down whatever you know and use that as your starting point to solve the problem. Okay, hope you guys are doing great. Bye.